quickly using GeoGebra. This can generate a much cleaner image, and it'll give me a chance to kind of go over a few more of the details. So here's the XYZ plane, right? You can see all the axes have their labels. And actually, one of the things you can do to make the picture a little bit easier to look at is you can add this gray plane. So what I've done is shade what is called the XY plane. So the XY plane is the set of all points in the three-dimensional space, which you see in front of you, that have a z coordinate of 0. All the points whose z coordinate is equal to 0 lie on that gray plane. Really what that is that's the Cartesian plane that you're used to thinking about. That's just the xy plane that you would have graphed parabolas and circles, ellipses, and all that stuff, right? That's the XY plane that you're familiar with from high school. So if you add that third dimension Z, now you've got what's called R3, or three-dimensional Euclidean space, or sometimes you might hear it referred to as Euclidean 3 space. All those terms mean the same thing. Don't worry about them too much. Just it's three-dimensional space. That's all you need to think about, right? So if you take all the points whose Z coordinates are 0, you're going to get that gray plane. But you could do that with the other coordinates as well. What if I take all the points whose Y coordinate specifically is 0? Well, then I'll get this brown plane, right? This is referred to as the XZ plane, because really, if you think about the points on that brown plane, they really, if their Y coordinate is 0, you could really just throw that away and really just think of them as two-dimensional points in that only need an x-axis and a z-axis. Or you could similarly do that by considering all the points in R3 whose x coordinate is equal to 0, and you would get this green plane, right? This is called the YZ plane. And all those planes have exactly one point in common. There's one point that lies on all three of those planes, and that's the origin, right? Which you can see there, just showed up in blue. Now, what about the point Q that we did in the previous example that had an x coordinate of 1, a y coordinate of 3, and a z coordinate of 2? Well, because I'm using software, I can plot that point a lot easier with just the click of a button. But it still doesn't really have much of a three-dimensional feel, does it? But I'm going to just hide these planes now because I think they just are a bit of a distraction. So if I look at this now, you can say, okay, I plotted the point Q. Well, that's not really all that helpful. It doesn't look like much of a 3D picture. It'd be nice to get more of a more substance here so it can take some shape. So if I were to just change the perspective temporarily, imagine that I'm looking just straight down on this. So I'm going to, in fact, the z-axis, imagine we're like looking down from above. You can see the z-axis has kind of disappeared because it's pointing so directly at us that we lost perspective of it now. Well, if I look down at the point Q and I imagine the sun, imagine you have the same perspective as the sun and you're directly above the point Q. Well, you would cast a shadow in the XY plane. And that's exactly what's happened. I've advanced the frame, but you can't see that shadow yet until I move perspective. But if I change now, you can see below the point Q, there's that shadow. Okay, and I could do the same thing by looking at it from this perspective where I'm directly staring at it along the y-axis. So the y-axis is pointing directly at us, and we could put a shadow behind the point Q that way. So it's going to leaves a shadow in the XZ plane. And then similarly, if I gave it this perspective, I could shine a light on the point Q and it would leave a shadow in the YZ plane. And that would leave black point that you can see. So now those 3 points together give some indication of, give us some way to kind of think about the location of the point Q, but it really comes together when you add those hyphenated line segments. So I'm just going to add those now. Those are the ones that I just drew in the previous picture, but now they look quite a bit more crisp when you generate them using software, right? So now you can really see where that point Q is a lot easier. It's not a cube, it's a rectangular prism, but it gives you a sense of where that point Q is. And then if you want to plot it as a vector, right, plot the vector as a position vector going from the origin to the point Q, like that, using the arrow, you can do that. So this is what it looks like if you generate the picture using software, and you can rotate it and get a look at it from different perspectives and really kind of see what's happening. And so when you get pictures that have multiple vectors, it's a lot easier to generate them using software.